Welcome to our lecture online. Our next problem is also a very interesting one and a rather challenging one. Let's say that we have a piece of wire. It is 12 meters long, and we're going to cut that wire into two pieces, each piece used to make a particular figure. One of them is square, the other one is circle. So let's say here we start with a 12-meter long piece of wire. We cut it into two pieces. We don't know how big each piece should be, and that's the question. How big should each piece be so that we'll have a maximum and a minimum area between the two figures? We know that the length of the one piece for the square is going to be 4 times the size of the square, and the length of the piece for the circle is going to be 2 pi r. If we call the area of the circle A1 and the area of the square A2, we then know that the total area is simply going to be the sum of these two. So now the next thing we're going to do, because we already have a diagram showing what the problem is all about, the next thing we're going to do is determine what's going to be maximized or minimized. So in this case, we're going to both maximize and minimize the area. So max and minimize the area of the two figures. So we need an equation. And we know then that the area is going to be the sum of the area of the circle plus the area of the rectangle. Now the area of the circle is going to be equal to pi r squared, and the area of the square is going to be s squared. Now notice we now have an equation that we can find the maximum or minimum area for, but notice we have dependency on both the radius of the circle and the side of the square. So the next step is we're going to need a constraint to be able to relate the radius of the circle to the side of the square. Step 4, we need a constraint. Now the constraint tells us that the total length should equal the circumference of the rectangle plus the circumference of the circle. And we know that the length is 12 meters, so 12 equals 4s plus 2 pi r. There's our constraint that allows us to relate s and r to each other. Let's see here. I think we want to get rid of the r. So let's solve for r. What we can do here is divide both sides by 2. That gives us 6 equals 2s plus pi times r. So pi times r equals 6 minus 2s, 2s, that should be an s, and r can now be written as 6 minus 2s divided by pi. So that's step number 5. We're going to now take that relationship and plug it back into our equation. So for step number 5, we get the area is equal to pi times the area, not the area, but the radius squared, which is 6 minus 2s divided by pi quantity squared plus s squared. Working this out, so we can say this is pi squared, 1 over pi squared times pi, that's 1 over pi, so area equals 1 over pi times, we have 36 minus twice the product of each other of these two, that's minus 24s and plus 4s squared, and then plus s squared. And now we're able to take the derivative of that and set it equal to 0 to solve for s. So let's go ahead and do that. So next, on number 6, we're going to take the derivative. That means a prime is equal to 1 over pi times, so that the derivative constant is 0. We get minus 24. And here we get plus 8s. And then plus 2s. And we're going to set it equal to 0 and solve for s. So set a prime equal to 0. So when we set this equal to 0, we get 0 is equal to 1 over pi times minus 24 plus 8s plus 2s. And then what I think I'm going to do is multiply both sides by pi. That'll give us the following. So continuing here, we get 0 is equal to, that disappears, we get minus 24 plus 8s, this should be an s, not a very good s here, s. And then multiply this times pi, so we get plus 2 pi s. Bring it to the other side and factor out an s. We get 24 is equal to s times 8 plus 2 pi. Notice we can divide everything by 2, so we get 12 is equal to s times 4 plus pi, or s is equal to 12 divided by 4 plus pi. So now we have a value for the length of the side of the square here, as being 12 over 4 plus pi, and if you want to get an approximate value for that, so we have 4 plus pi inverse times 12 equals, that's about 1.68. So s is equal to about 1.68, and I guess we were dealing with meters. All right, so that gives you an approximate length for the side of the square. Now, since we have the radius of the circle expressed in terms of s, we can use that to find the radius of the circle. So we have r is equal to 6 minus 2 times s, and s was 12 divided by 4 plus pi, and then divide the whole thing by pi. So what we can do here is say r is equal to, that would be 24, 6, that would be 6 times 4 plus pi, because we want to put over a common denominator, so it would be 6 times 4 plus pi, and that would be minus 24 divided by 4 plus pi, 4 plus pi, and the whole thing divided by pi. Okay, we're almost there. So this is equal to 24 minus 24, and then we have pi there, so we have pi divided by 4 plus pi over pi, which is equal to pi squared over 4 plus pi. So now we also have a value for the radius of the circle, and to get a feel for that being somewhat correct. So, well, pi squared is about 10 divided by about 7, so that's about 1.3 or 1.4, something in the neighborhood. So that looks fairly good as well. Now, did we find the maximum or minimum values by finding the value for s and the value for r? Let's go back to the original equation here. We have the area in terms of, well, let's go here, in terms of s right here, or maybe here. Let's go to this equation right here. Notice this is a quadratic equation, and notice that the square terms are both positive. Quadratic equation where the square terms are both positive, that means we have a parabola that opens upward. And so since we use that equation to find r and s, that means that these are the values for r and s, which indicate the sizes of the rectangle and the circle, that will give us the minimum value of the area. So this gives us a minimum value. So how do we get the maximum value? Well, the maximum value will be obtained when we use the entire what I'm looking at, wire, looking for the word, the entire wire to either make a square or to make a circle. Okay, so what would be the area be if we used all of the wire to make a square? Well, since the wire is 12 meters long and there's 4 sides, that means each side would be 3 meters, and then the area would be 3 times 3 or 9 square meters. So the area of a square, if we use all of the wire for the square, that would be equal to 9 meters squared. Again, we have 12 meters of wire, divided by 4, that's 3 meters for each side, 3 times 3 is 9. Now, what if we used the wire to make a circle? What would be the area of the circle? So, well, I'm really running out of board space, but let's see here. I don't like to erase anything, but maybe I have a little bit of space right here. So notice we're going to take the entire circumference and set it equal to 12 meters. So the circumference, which is 12 meters, is equal to 2 pi times the radius. That means that the radius is equal to 6 divided by pi. And we know that the area of a circle is pi r squared, so the area of a circle is equal to pi r squared. So it would be 6 divided by pi squared times pi. That would be pi times 36 over pi squared, or 36 divided by pi. So the area of the circle is going to be, if we use the entire wire for a circle, we take 36 divided by pi equals, and we get 11.46. 11.46 meters squared, which means that if you take a wire and use the entire length of the wire to only make a circle and not a square at all, you will end up with the largest area. If you want the minimum, then you take the wire, cut into two pieces, one for the square and one for the circle, in such a way that the side of the square will be equal to this, and the radius of the circle will be equal to this. And that's how it's done.